Good morning, Year 3. Today I'm going to talk you through types of graphs or charts, which is our new topic in maths. So what I'm going to do is I'm going to show us a couple of different types of graphs or charts, talk you through how we understand them, how we read them, and then you've got a couple of activities that you will do following this video. So, first of all, our first one that we're going to look at is called pictograms. Now I can hear the word picto in there and that makes me think of picture. So I'm imagining this one must have something to do with using pictures to display information. So let's have a look. Here we've got two pictograms that actually say the same information, even though they look a little bit different. And I know that because they both have the title, a pictogram to show how the children in Key Stage 2 travel to school. So even though they look different at the moment, they do tell us the exact same information, and we'll find out why in a moment. So it says here, a pictogram uses pictures or symbols to represent discrete data. All that means is discrete data is information that can be counted. So things like how many girls are wearing a bow in their hair. I would be able to count that and I'd be able to jot that down. So discrete data is just information that I can count. And a pictogram uses pictures or symbols to represent that data, to show it in different ways. These pictograms are using circles, but you might find pictograms that use apples or TVs. It can be any picture so long as you use a key. Now this key tells me what each one of those pictures represents. So what does each of those pictures mean? What is the value of it? How many is that picture meant to show? So in the top one, you can see that the key means every circle is equivalent to, which means the same as, 2 children. But in the bottom one, the key for one circle is equivalent to, which means the same as, 4 children. So that is why, even though those two graphs shows the exact same information, they look different because the value of their picture is different. So it says here it is important to identify the value of the whole picture or symbol in a pictogram, as part symbols are often used to show different values. So I can see a whole circle, if we look at the top graph, shows us 2 children, which means those half circles there must be half of the amount of the whole. Well, I know that half of 2 is 1. So a half of that circle must mean 1 child. So I'm just going to count now just to see what they mean. So if every whole circle is 2, that means if we look down at bicycle here, I've got to count in 2s to see how many children took the bike to school. So 2, 4. Okay, let's double check down here. This time it says the key is 4 children. So this time I'll be counting in 4s for every whole circle that I see. So let's look at the same one again. Bicycle. And there's only one circle and that equals 4. So is that the same? Yes, it is. Let's have a look at these part symbols then. If I looked at walking, so at this time counting in 2s. So 2, 4, 6, 8, 10, 12. And a half circle, which I already said was 1. So 12 add 1 equals 13. Let's double check if it's the same on the graph below. Remember, this time the circles don't equal 2, they equal 4 children. So I'm counting in 4s this time. And there's 3 lots of those, so it's 3 times 4. So 4, 8, 12. This isn't a half, it's a quarter of a circle. So a quarter of 4 equals 1. So again, I've got 12 as a whole amount here. Add that 1 is 13. So it is the same as the one above. It just shows it in a different way. In both of these pictograms, the data is the same, but the value of the symbol is different. So the key to remember with pictograms is you must look at what the whole picture is worth, and also be really mindful to look at whether that is a half a circle, a quarter of a circle, or if we look here, I've got 3/4 of a circle. So that is doing a fraction of the whole amount of the original picture. So that's how we interpret and gather data from pictograms. The next one we're going to look at are bar charts. Now you've probably come across bar charts before, because one thing that we use with bar charts is tally charts as well, and I will go over those shortly in a moment as well. So again, bar charts are used to collect discrete data that is counted and has no in-between value. So it's usually collected in a frequency table and then it's presented as a bar chart. So let's have a look. Here's all my information. This is the frequency table. I've gone around and I've asked everybody how many children have a cat, how many children have dogs, how many children have fish, and I can already see only 7 children have fish, but 12 children have cats. So I can look at my information like that already, but it's easier and more effective if I transfer it into a bar chart. So a bar chart has a horizontal axis and a vertical axis. It must have a title to explain what the bar chart shows. So in this case, if I look at the title, it says a bar chart to show how many pets Year 6 have. So I know what this information is now because I've made my title very, very clear. The bars must be carefully drawn to show the data. You have to be very, very neat with bar charts. You must use a ruler and a pencil. It also says there must be a gap between each bar, so it's not a proper bar chart if you haven't got gaps between your bars. And it says each bar must be the same width. So if I was doing this in our squared paper maths books, I would probably make sure all of my bars were only 1 square wide. They are the same width. That means the distance going across. They're not all different widths, they're all the same. You might also notice that the horizontal and the vertical axis have also got titles. So I can see that this information is the type of pet and this information is the number of children. It's really important to put that on there as well. Otherwise we wouldn't know how to read the bar chart. A number line is marked on the vertical axis. So this one here, that's your number line. The scale of this number line is chosen based on the data range because I can see up here it only goes up. The biggest value there is 14. So it doesn't have to go a huge way up. And I can see that the person who's made this one has decided to scale that going up in 2s. But they haven't stopped at 14. They've done the value above 14 so that we can get a nice clear picture at the top there. And they have started on 0. This bit here is called the origin point where both of the axes meet. So it's always a 0. If my values up here were higher, so let's say that was 140, going up in 2s would take me so long. So I might choose a different scale. If it was 140 instead of 14, I might choose to go up in 10s instead or 20s. And that way each gap would have a different value as well. So you have to choose your value and scale very carefully. The data categories are organised on the horizontal. So this is the information that I actually wanted to gather. This is what I wanted to find out. So you must label them both, otherwise they're not going to make sense. And then all you do is you take that information there and you very neatly draw the bars to represent each of those data collection points. And I can visually see, without even having to look at the scale on the side, I can see there the biggest bar is dog. So that means more children own a dog. And without even looking again at the scale on the side, the smallest bar is rabbit. So that means less children own a rabbit. So those are two of the charts and graphs that we will be looking at over this unit.